Hello, how's it going? Welcome back. Today we're going to be talking about IPv6. Now we know there's an early adoption going on, and we're going to talk about the security considerations really, and how we can go about putting into place solutions and look at our countermeasures. But ideally what we're talking about here is the transition from IPv4 to IPv6. Now this is a revolution here, right? It's going to give us, more addresses. We were used to the 32-bit. That 4 octets, now we have 128-bit addresses. So you're going to have a lot more of addresses to obtain because 32-bit IPv4, we're running out of addresses. All right, as time goes on and as we create more nodes and more machines and everything else connects to the network. But some of the new features are going to be the auto configuration. When we're talking about router advertisements as well too, being able as well to have what's called a stateless address. Now, being able to understand how to configure an actual device to let it self-configure itself or a whole IP address, right, without the use of DHCP, that's very important. Because as we know, the usual router is going to be that DHCP router as well too, or at least have that feature to be able to automatically assign these IP addresses. Now, one of the other things to keep in mind is when we're talking about transitioning from IPv4 to IPv6, it's going to create a few challenges, and we'll go more into that. But one of the key things is understanding what risks are associated with it. So think about how attackers, they can exploit and take use or advantage of a misconfiguration. Now, being able to have mitigation in place like monitoring tools, being able to decapsulize packets, right? Being able to actually do packet analysis at that level is, crucial. One of the other solutions you can look into doing though is creating some isolated traffic or inspecting the traffic that's going in through the actual tunnel itself with deep packet inspection. Now, we talked about DPI before. We talked about the use of what does that look like? How do you even do that? Right? Now, one of the things though to keep in mind with our security vulnerabilities is this. There is something called IPv6 abuse, where we're talking about how we rely heavily on the NDP protocol, and that's stateless auto configuration I talked about earlier. Now, one of the attack vectors though, think about the exploitation of IPv6, the messages themselves. You can actually exploit that to conduct an actual DDoS attack. Why not? Or spoofing, right? Because you're sending, right? You're doing router advertisements, or at least rogue router advertisements, because you're trying to misdirect people. Because think about it, if you're looking at Wireshark, within Wireshark, you will absolutely see on the network something being advertised. That router says, hey, who has this IP address, right? So you will have that. So understanding how to actually look at this from that perspective will be good. Now, you want to be able to address the privacy here. So IPv6, you're going to have the embedded MAC addresses, right? So this is going to assist in that, I'm going to say overcoming the fingerprinting issue, but usually it's still going to be there, right? Because it's very risky. Now, using a temporary address will help with this though. And understanding if you're using Windows or Linux, how to randomize your addresses is key as well. Fragmentation has been one of the other things too to keep in mind because, attackers, they will absolutely use header fragmentation to bypass that firewall, to bypass the IPS, because that's what it's doing. It's looking directly at that header. And if it doesn't see anything wrong, it's going to bypass it. It's fragmenting out the actual payload, the actual portions of it that make it malicious. So you want to be able to protect your network during the adoption of IPv6, which again, you're just taking into account that there are more addresses that can be utilized, integrating DNSSEC, and being able to understand the routers and the switches and how they play their role, and being able to review the router roles within the actual router itself to block unauthorized advertisements that are basically saying, hey, I'm this router, and it's really not. So some best practices, training your personnel to identify these use cases that we talked about, to actually adapt an ACL to handle IPv6 traffic, and then using those native tools like RA Guard. Let's talk about our example here. We're talking about setting up an IPv6 firewall. What does that mean? Well, we're talking about a cloud-based Azure firewall. We're talking about being able to understand that it has its own headers as well too, and then using security groups to enforce the access control is really going to allow only the messages that we want to come through, not any attack or any advertisement or anything that's not necessarily actual good traffic. And then being able to regularly simulate actual packet fragmentation, because, again, think about it. If you're testing a network, if you are trying to understand what that looks like if someone is trying to send fragmented packets, you want to do that. You want to be able to simulate that. Again, it's been great. General, CEO of Cortex Solutions, and today we talked about IPv6 security configurations and then their consideration around the adoption of that. Brought to you by ACSMI. Hope you have a great one. Take care.